All right. I wanted to make sure we saw an example of kind of maybe one of the more complex equations that we've seen thus far. This shows up on your homework. There's a couple of them here. The last two questions are going to deal with a confidence interval for the difference in means. So we're going to walk through number 14 just so y'all can see an example of how we go about doing a problem like this. So in this one, we're looking at two different groups. A study of parental empathy for sensitivity cues and baby treatments was performed. Let X1 represent the mother and let X2 represent the father. So we want to see if there's a difference in empathy levels for mothers and fathers. And so we randomly sample 38 mothers, and we see that they have a sample mean X bar 1 of 69.04. And then we sample 38 fathers and see that the X bar 2 for them is 58.7. And now we have population variance, sigma 1, that's for the mother group, is 11.13, and sigma 2, that's for the father group, is 11.03. So we want to construct a confidence interval for these to see whether or not there is a significant difference between these two groups. So we're going to answer each one of these questions, and I'm going to do the work on the board because SALT doesn't have the ability to do this problem as of right now. So let's go through this. When you see this question, what distribution should be used? Thus far, we've only learned about the standard normal. We haven't learned about the student's T. That's going to show up in week 6. So that shouldn't ever be the answer. But the general answer is we're going to use the standard normal because sigma 1 and sigma 2 are both known. Since we know them, we're going to use that standard normal. So as we are going through and we're taking a look, what we're going to do is we're going to go back and remind ourselves what were those formulas to help us find these things here. So as we took a look here, in order to find this, we were going to find our standard, confidence interval for the difference in means as follows. We're going to take X1 bar minus X2 bar plus or minus our margin of error, where our margin of error is equal to our critical z-value multiplied by the square root of sigma 1 squared divided by n1 plus sigma 2 squared over n2. So we're able to find our values there as we take a look. So I've got that written on the board right now. And so what I'm going to do is I'm just going to figure out what this confidence interval is. So the key things we know that we want to construct a 99% confidence interval. So my critical z-value is going to be 2.576. I have x1 bar, x2 bar, I've got sigma 1 and sigma 2, and I have n1 and n2. Those are all the values I need to have in order to solve this. So x1 bar is 69.04, x2 bar is 58.7, 58.70. I've got sigma 1 is 11.13. I've got sigma 2 is 11.03. In both sample sizes, in this case, were 38. So next, I want to compute my margin of error here. And I also want to compute that difference in mean. So we're going to have to compute both of these things. So I can use my equation here to help me find out what that margin of error is. Z critical multiplied by the square root of sigma 1 squared, 11.13 squared over n1, 38, plus sigma 2 squared, 11.03 squared over 38. And that's going to give me my margin of error. So now we have to plug this into our calculator, and we just need to be extra careful when we do, because we kind of have a lot of stuff going on when it comes to these things. So we want to just make sure that we're extra careful, and if you need to be, and I always like to do this myself, is just make sure that I'm doing these things right and I'm not going to make any mistakes, I can write in these values here just to make sure, and then how to do it step by step if you prefer. It helps us make kind of fewer mistakes. The challenging part is we have to write down all these numbers as we do it, just because we don't want to round too early. But now we can get our answer here. We can take the square root of that, and then we can multiply that by 2.576, and I get a margin of error of approximately 6.548. So there's our margin of error. What we need to do next is find x bar 1 minus x bar 2. So we just use those values there, 69.04 minus 58.70. And again, we're going to plug that in just to make sure we don't make any mistakes on this. And we get a difference of 10.34. So now we're going to take this quantity here, and we're going to buffer it by our margin of error. So my lower bound is going to be 10.34 minus 6.548. And then my upper bound is going to be 10.34 plus 6.548. So we're going to use calculator again just to make sure that we get the right values. So when we do that first one, we get a lower bound of 3.792, and we're going to get an upper bound of 16.888. So now I've got my lower bounds, I've got my upper bounds, and I'm able to input the rest of the questions when it comes. So now let's take a look at finishing off this problem and how we would enter it in as we go through. So let's go back to that problem. We already had part A done. We're going to use the standard normal because we know the standard deviations of population. And then we can enter our results here, right? The way they want us to do this is lower bound, then the word 2, then upper bound. So our lower bound was 3.792. It wants us to round it to 2 decimal places. So that's going to give me 3.79 to upper bound 16.89. And so now we've constructed our 99% confidence interval for this one right here. Last, examine the confidence interval and explain what it means in the context of this problem. So when we take a look at this, the key indicator is the value of 0 somewhere in between my lower and upper bound? If it is, that means the lower bound will usually be negative and the upper bound will be positive. Both of these values are positive. That means 0 is not in the interval. That means that there is, in fact, a significant difference between these. So that means x1 is, in fact, larger than x2 from a statistical standpoint. So we would read, because the interval contains both positive and negative numbers, it doesn't. Because the interval contains only positive numbers, that's the case, we can say that mothers have a higher mean empathy score. That's going to be the correct choice for sure. But let's go through the rest. We cannot make any conclusions. That's not true. We sure can. Because the interval contains only negative numbers, we can say that the fathers, well, that's not the case here. So that's how we go about doing this type of problem. It is just a little bit of work. We have formulas that we need to plug values into. They give you all the values that you need. The hardest part is going to be plugging the things into the calculator correctly. So that's that. Hope it helps.